current world, we have a problem we wish to remain oblivious to because we don't think it is our problem. However, it is. Our crude oil banks are depleting at a rapid rate, and by 2069, there will be no more crude oil left in the world, a vital ingredient for many goods that we produce. As our oil becomes scarcer, prices will increase for everyday essentials such as fuel, and your average family won't be able to afford to run their most required possession, their vehicle. Our world would come to a standstill, our way of living gone like a few final drops of oil. Unless, of course, we find a major alternative to fuel our future. As a society, we have already invented some ways of powering our vehicles without petrol, such as hydrogen cells or electricity. But what if we use the very chemical we exhale from our bodies to power our vehicles? Carbon dioxide can be useful for more than just a waste product for respiration. Take photosynthesis, for example. By taking carbon dioxide and water, plants create their own food supply and in turn energy in the form of adenine triphosphate. What if, somehow, we used a similar process to photosynthesis in order to feed our vehicles? Rather than taking your vehicle to the petrol station for petrol, you can just take a ride. Your vehicle can be self-sustaining and never run low on fuel. My proposed idea is to create an alternative form of energy source to run vehicle engines based on the capture of carbon dioxide and water, in which the ultimate goal is to have oxygen as a waste product. Nowadays, many of our vehicles run on petroleum, and as a waste product, they produce carbon dioxide and carbon monoxide, which is contributing to the carbon dioxide levels in the atmosphere. My idea is to reverse this, therefore decreasing the carbon dioxide levels and increasing oxygen levels, much like photosynthesis does with plants. A downside to the idea I've proposed is that it might not be as useful in areas where there is a low concentration of carbon dioxide emissions. This means that further advances in technology will have to be made so that these engines can run wherever you are in the world. The upside? We will be decreasing the carbon dioxide levels in the atmosphere and possibly even eliminating our contribution to the levels with the use of many vehicles. In 2013, the ratio of carbon dioxide to the Earth's atmosphere had surpassed 400 parts per million at Hawaii's Mauna Loa Observatory. This has been the highest concentration of carbon dioxide in our atmosphere for millions of years. To give you a comparison, the ratio of carbon dioxide was around 280 parts per million in pre-industrial times. To decrease this ratio, we would have to create something that takes carbon dioxide in and releases another particle. For the vehicle engine to run, it will have to extract carbon dioxide from the atmosphere. However, at only 400 parts per million, this will deem quite tricky. Carbon dioxide can be captured from exhaust stacks through carbon capture. Air Liquide is doing this at Marsden Point Refinery, located in Whangarei. However, the carbon dioxide concentration in the flue gas which is released from these exhaust stacks is relatively high compared to the air. If we are able to capture carbon, possibly through the filters in the car made from porous materials as people in the University of Bath are developing, we would be able to convert carbon dioxide into a hydrocarbon through the reaction known as the Fischer-Tropsch process. A British company called Air Fuel Synthesis is developing this using this process. For this reaction to occur, we require the hydrogen atoms from water and the carbon atoms in carbon monoxide. We have to convert carbon dioxide into carbon monoxide by removing one of its oxygen atoms. However, carbon dioxide is a very stable molecule, so any conversion processes will take a lot of energy. We can incorporate solar cells to provide the energy to break the bond between one of the oxygens and the carbon atom. After this, through electrolysis, the method of having a direct electrical current to drive an otherwise non-spontaneous chemical reaction, the hydrogen is isolated from the oxygen particles in the water and reacted to the carbon monoxide to produce a liquid hydrocarbon. A hydrocarbon is an organic molecule that consists of only carbon and hydrogen atoms. This energy source will provide the future human generation with eco-friendly, sustainable modes of transportation and will be very useful in regulating the carbon emissions in the atmosphere. All this said, why would it benefit New Zealand? We're a country of farming and not that large in size. Firstly, if New Zealand creates a car that runs on carbon dioxide and presents it to the world, it would revolutionise our clean green image. This is attractive to many tourists which come here to see our beautiful green country. This will most definitely increase the demand for tourism, and this links to the business ventures my idea can create for New Zealand. Due to the decreased carbon dioxide levels, our industries will be able to expand in the most efficient way. The issue of pollution will not be such a prominent problem if they produce carbon dioxide at a certain radius from a densely populated area. This means businesses will be able to increase their carbon footprint without having to be concerned about excess pollution, and in turn, they would probably be able to increase their productivity. There would be limited concern of the increased carbon footprint, as we would be counteracting the carbon dioxide levels in the atmosphere, as we would reduce this gas through the use of our vehicles. This will, in turn, boost our economy and bring more money into New Zealand to boost public systems such as education and health, while also increasing the net social welfare, which is a form of economic growth. Many New Zealanders are against drilling for crude oil in our many oil banks dotted throughout New Zealand and its borders. If New Zealand and the rest of the globe incorporate vehicles that run on carbon dioxide and excrete oxygen as a waste product, we will deplete our need for excavation of oil by vast quantities, and will have a surplus of oil in order to produce products such as plastic and fertilizers, which is essential for our survival with a population this big. As carbon dioxide emissions are a global issue, we will also have a global market to sell our vehicle engines to. There are many factors that this revolutionary idea can create. These factors include, but are not limited to, environmental, social, health, and wealth factors. As there is a decrease of carbon dioxide levels in the atmosphere, especially in densely populated cities, there will be an improvement in public health and well-being. A social factor is that the vehicles will be affordable to run. This means that we will be not as limited in our travels, and we will have more discretionary income to spend in other areas. This factor links in with a wealth factor, because the vehicles will be self-sufficient. In other words, the fuel will be somewhat free. Lastly, a health factor for New Zealanders is that we will create healthier ways of transportation, because the waste product would be oxygen instead of carbon dioxide, which will reduce the carbon dioxide poisoning and smog in large cities. Thank you for listening about my proposed idea. With oil running out within our lifetime, it's time we start looking at other alternatives, which I believe these carbon dioxide-fueled cars will provide us. Using this pre-existing material, we can save our reserves while further benefiting our environment and ourselves. I hope to see many vehicles on the streets that run on carbon dioxide in the near future, thus producing cleaner air for us and other animals to breathe in, and in turn, fueling our future.
Thanks, Emilie. How would the fuel be somewhat free, given that somebody's got to make it, right?
Well, it will be free in the money sense for a consumer, because we won't be having to spend our money on such as petrol.
But we'll still have to make.
Yes, we would, but we're already making it in the forms of the industries, such as any industry which produces smoke or carbon dioxide.
But then you would need to convert it, and that would be expensive, would it not?
That would be in the filters.
And the solar energy?
Yes.
And how much solar energy would you need to convert a viable amount of it?
From the top of my head, I think 1 gallon of water to be boiled is 18 kilowatts. I'm not too sure. I'd have to check up on that.
We're talking about a lot of solar energy, right?
Oh, sorry. I'm guessing it would be 18 kilowatts as well.
But, I mean, are we equipped to translate that amount of solar energy into what you need?
Well, with further advances in technology, which would be very beneficial, we would be able to.
You mentioned that it would be problematic where there's lower carbon dioxide.
Yes.
Where are you thinking about?
Areas where there is not as much industries, like farmland, possibly.
Right. Do you have any idea how variable it is? I mean, as you mentioned, we're told that it's, set for 400 parts per million.
Yeah.
Do you know, as a matter of interest, this is off topic really, but how variable that concentration of CO2 is around the place?
I'm not too sure, because that was set at a certain place in Hawaii.
Yeah.
Yeah.
I mean, I know.
But it should vary.
It's the IPC thing. Thank you.
You're welcome.